Alright, in our second lesson on equilibrium, we're going to figure out how to deal with some more complex free body diagrams. We're also going to work with elastic springs, and we're going to look at examples with pulley systems. Right, so the big thing to remember from your physics experience is that one way to model flexibility or stiffness in a system is by looking at, well, if we pull on something, how much force corresponds to how much the elongation is. And if we plot that spring force and that corresponding elongation, what we find in a lot of systems is that they are linear in their variation, and when we unload, they go back to no permanent deformation, and the slope that describes that relationship between those two is the spring constant. So in that y equals mx plus b, where b is the intercept, in that basic linear model, Fs, the spring force, is equal to the spring constant times delta, that deformation. Now in physics, you probably call that deformation x, and we don't use that symbol because for us in our work, x is going to mean position where we're at somewhere, rather it's a coordinate as opposed to a change in length of something. So Fs, the spring force, equals that spring constant k times delta. In the mechanics of materials course, you'll begin to learn how we predict what that value would be, rather than just only having to always do this empirically, get the device out, pull on it, measure the deformation, and do it at a variety of different locations along here, and then go figure out what that modulus or that slope is. We can predict what that's going to be for a lot of different kinds of situations, and you'll learn about axial stiffness and all kinds of other stiffness. You'll learn about the material stiffness, the rigidity of the cross-section. All these kinds of things will play into our models for that stiffness value. You'll see that coming up in future classes.